Not long ago, specialized chips were something most consumers never thought about. Processors were just expected to be faster each year, and whatever happened inside the device was largely invisible. Today, that has changed. US tech companies are openly talking about neural engines, AI accelerators, and dedicated AI chips as selling points. These components are no longer limited to data centers or high-end servers. They are showing up in laptops, smartphones, tablets, wearables, and even home devices. This push is not about hype. It reflects a fundamental shift in how everyday devices are designed and what companies believe the future of computing looks like. The primary reason US tech companies are pushing AI chips into everyday devices is efficiency. Traditional processors were designed to handle a wide range of tasks reasonably well, but they are not optimized for artificial intelligence workloads. AI tasks like image recognition, language processing, and pattern detection require massive parallel calculations. Running those tasks on a general-purpose CPU is inefficient and power-hungry. Dedicated AI chips are designed specifically for these operations, allowing devices to perform AI tasks faster while using significantly less energy. Battery life is a major driver behind this shift. As devices become more capable, managing power consumption becomes harder. AI chips allow companies to run intelligent features without draining batteries. By offloading AI tasks from the main processor to a specialized chip, devices can stay responsive and energy efficient at the same time. For consumer gadgets, this balance is critical. No matter how advanced features become, users still judge devices by how long they last on a charge. Another key factor is performance consistency. Without AI chips, devices often rely on cloud processing for intelligent features. This introduces delays, depends on internet connectivity, and creates inconsistent experiences. By embedding AI chips directly into devices, US tech companies ensure that AI features work instantly and reliably. Tasks like voice recognition, photo enhancement, noise cancellation, and predictive text can happen in real time, even without a network connection. This reliability is becoming a baseline expectation. Privacy concerns are also accelerating the move toward on-device AI chips. When AI processing happens in the cloud, user data must be transmitted, stored, and analyzed remotely. This raises concerns about data security and regulatory compliance. AI chips enable on-device processing, keeping sensitive data local. For US companies operating under increasing scrutiny around privacy and data protection, this approach reduces risk while improving user trust. Cost structure plays a significant role as well. Cloud-based AI is expensive to operate at scale. Every AI request processed in the cloud consumes server resources, energy, and infrastructure. By pushing AI processing onto devices, companies reduce long-term cloud costs. While designing custom AI chips requires upfront investment, it lowers operational expenses over time. This economic incentive becomes especially important as AI features move from novelty to everyday usage. Competitive pressure is another major driver. Once one major US tech company demonstrates meaningful benefits from AI chips, others are forced to respond. AI chips become a differentiator not just in performance but in future readiness. Devices without dedicated AI hardware quickly appear outdated. As competition intensifies, AI chips move rapidly from flagship products into mid-range and mass-market devices. The rise of AI chips is also tied to software evolution. Operating systems and applications are increasingly built around machine learning models. Features like system search, photo organization, accessibility tools, security monitoring, and performance optimization all rely on AI. Dedicated AI chips allow these features to run continuously in the background without slowing the device. As software becomes more AI-dependent, hardware must evolve to support it efficiently. Another reason AI chips are spreading into everyday devices is thermal management. Modern gadgets are thinner and more compact than ever. Heat is a major limitation. Running AI workloads on CPUs or GPUs generates significant heat, which can lead to throttling. AI chips are optimized to perform these tasks with minimal thermal impact. This allows manufacturers to maintain slim designs while delivering advanced functionality. Enterprise demand also influences this trend. Businesses upgrading large fleets of laptops and mobile devices want hardware that will remain capable for several years. AI chips are positioned as future-proof components that support upcoming software updates, security features, and productivity tools. For enterprise buyers, this reduces the risk of early obsolescence and increases long-term value. Security is another important factor. AI chips support advanced on-device security features such as behavioral monitoring, anomaly detection, and real-time threat response. These capabilities are more effective when processed locally and continuously. As digital threats grow more sophisticated, U.S. tech companies are embedding intelligence directly into hardware rather than relying solely on software-based defenses. AI chips also enable personalization at scale. Devices can learn user habits, optimize performance, and adapt interfaces without sending personal data off-device. This allows companies to offer personalized experiences while maintaining privacy boundaries. Personalization becomes faster, safer, and more reliable when powered by local AI hardware. Importantly, this shift is not about turning every device into a data center. It is about distributing intelligence. Instead of centralizing all AI processing in massive server farms, U.S. tech companies are spreading intelligence across millions of devices. This distributed approach reduces latency, improves resilience, and scales more efficiently as AI usage grows. The push for AI chips is also influenced by supply chain strategy. Designing custom AI hardware gives companies more control over performance, integration, and differentiation. It reduces reliance on generic components and allows tighter coordination between hardware and software. This vertical integration has become a competitive advantage in the U.S. tech ecosystem. What makes this transition notable is how quietly it is happening. Most users do not interact directly with AI chips. They simply notice that devices feel faster, last longer, and work more smoothly. That invisibility is intentional. AI chips are meant to enhance experiences without adding complexity. Looking ahead, AI chips are likely to become as standard as graphics processors or wireless radios. As AI-driven features expand, devices without dedicated AI hardware will struggle to keep up. What feels like a trend today is rapidly becoming a requirement. In the end, U.S. tech companies are pushing AI chips into everyday devices because they solve practical problems. They improve efficiency, protect privacy, reduce costs, and enable smarter software. This is not a short-term experiment. It is a foundational change in how consumer technology is built, and it is reshaping the future of everyday computing one device at a time.